Hello everyone. So yesterday we have solved some problems of exercise 8.3 of trigonometry, and we have done, I think we have done up to question number fourth, and we have done first part of question number fourth. Okay, so now we will move forward and do the remaining questions. Now the second question is cos a upon 1 plus sin a plus 1 plus sin a upon cos a, and we need to change it in the form of sec a. So here we have cos, sin, cos. Okay, and we need to change it in the form of uh, sec a. We know that there is a relation of sec and cos, so we will try to solve it and change it in the form of cos so that we can get our answer in the form of sec. So the question is cos a upon 1 plus sin a plus 1 plus sin a upon cos a. Okay, so this is our left hand side. Okay, left hand side. So now if we take LCM over here, it will be cos a into 1 plus sin a. That cos a will turns to cos square a plus, here if we divide this by cos a, so we will left with 1 plus sin a, so it will be 1 plus sin a whole square. Now this will be cos square a. If we apply the identity, so it will be a square plus b square plus 2ab upon cos a into 1 plus sin a. Now here cos square a plus sin square a is equals to 1 plus 1 plus 2 sin a, and here we have cos a into 1 plus sin a. Now here 1 plus 1, we have 1 plus 1, 2 plus 2 sin a upon cos a into 1 plus sin a. So if we take 2 as common, so it will be 1 plus sin a upon cos a into 1 plus sin a. This 1 plus sin a, 1 plus sin a will cancel out each other. So we are left with 2 upon cos a. It will be 2 into 1 upon cos a, and we all know that 1 upon cos a is sec a. So this is our right hand side. So we have completed second part of question number 2. Now we will do part third of question number 4. So this question is here we have tan theta, cot theta, cot theta, tan theta, and we need to change it in the form of sec and cosec. Sec and cosec. So let's first change them in the form of sin and cos. Write the expression in terms of sin theta and cos theta. Here we have given hint. So I am taking left hand side. Left hand side is tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta. Tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta. Okay. So if we change it in the form of sin theta cos theta, tan theta is sin theta by cos theta whole upon 1 minus what is cot theta. Cot theta is cos theta by sin theta. Now here at plus again cos theta by sin theta whole upon 1 minus sin theta by cos theta. Now it will remain as it is, that is sin theta on cos theta. Here we take LCM. LCM will be sin theta. So now it will be sin theta minus cos theta plus this will remain as it is, that is cos theta by sin theta, and here we will take LCM. LCM will be cos of theta. Here it will be cos theta minus sin theta. Now this sin theta will go here and this whole term will go here. So it will be sin theta into sin theta, sin theta into sin theta, that will be sin square theta by cos theta into this cos theta into sin theta minus cos theta, sin theta minus cos theta is plus. Now this cos theta will go here and this cos theta minus sin theta will go here. Okay, so we are left with cos theta into cos theta, cos square theta by sin theta into cos theta minus sin theta. Now here we have sin square theta by cos theta into sin theta minus cos theta plus. Okay, now here we have sin theta minus cos theta, here we have cos theta minus sin theta. So if we take minus as common, so it will turns to sin theta minus cos theta, and this plus will be, this plus will change into minus. So here we take minus and it will be sin of theta into sin theta minus cos theta, because from here we take minus as a common, so plus minus equal turns to minus and here sign will change. Now if we take LCM over here, so LCM will be sin theta into cos theta and the common part is sin theta minus cos theta. Okay, so here if we divide this by this, so we will left with only sin theta, and if we multiply sin theta with sin square theta, so it will be sin cube theta minus, same here it will be cos cube theta. Okay, because we have divided by this, so we are left with cos theta, and cos theta will be multiplied with cos square theta and it will turns to cos cube theta. Now we have now as we know that it is turns to a cube minus b cube. And what is the formula of a cube minus b cube? What is the formula of a cube minus b cube? One formula is a cube minus b cube is a minus b whole cube. One formula is a minus b into a square plus b square plus ab plus ab upon it will be sin theta into cos theta sin theta minus cos of theta. So that part will cancel out this part. Here we are left with sin square theta cos square theta will be 1 plus sin theta into cos theta whole upon sin theta into cos theta. Now if we split it, so it will be 1 upon sin theta into cos theta plus here we have sin theta into cos of theta upon sin theta into cos theta. Now this sin theta, sin theta, cos theta will cancel out each other. So here we are left with 1. Okay. And now 1 upon sin theta, 1 upon cos theta. So I am writing it here. So we have 1 upon, like split it, 1 upon sin theta into 1 upon cos theta plus 1 upon sin theta is cosec theta, 1 upon cos theta is sec theta. So it will be cosec theta into sec theta plus 1. I think, and that is our right hand side. That is our right hand side. So now we have solved second part of question number 4th. Not second, but we have solved third part of question number 4th. Okay. So now moving forward, we will solve now see the fourth part. Okay, we have 1 plus sec upon sec a is equals to 1 sin square a upon 1 minus cos a. So we have to change sec into sin or cos. Here we have hint that simplify left hand side and right hand side separately. Okay, so in this question we need to solve left hand side and right hand side separately. So first take the left hand side. We have left hand side, that is 1 plus sec a by sec a. Now try to solve it. It will be 1 upon sec a plus sec a upon sec a. So 1 upon sec a is cos a plus this will cancel out each other. It is cos a plus 1. And if we take right hand side is sin square a upon 1 minus cos a. Now sin and cos have relations. We know that sin square a is 1 minus cos square a upon 1 minus cos a. Again here we have identity a square minus b square. So it will be a plus b into a minus b upon 1 minus cos. So this 1 minus cos a will cancel out 1 minus cos a, and we are left with 1 plus cos a, 1 plus cos a. So therefore we can say left hand side is equals to right hand side, because we have solved left hand side and right hand side separately and we got the same answer. Okay, now we should move to the question number 5th part. We should move to the 5th part of question number 4th. Now in 5th part we have cos sine plus 1, cos sine minus 1, and we have cosec a cot a. We need to change it in cosec a plus cot a, and we are given here use identity this. Okay, now cos sine cosec cot upon cos sec 1 upon sine cosec. Sec and cosec does have any relation? No. if we change this one as a sine square a plus cos square a, so it will be let's see, we take left hand side. So here we have cos a minus sin a plus 1 on cos a minus sin a minus 1. Here we have given a hint that use the identity cos square a is equals to 1 plus cot square a. Cosec square a is equal to 1 plus cot square a. And 1 is equals to 1 minus cot. Cosec cot. If we divide this by sine. Okay. Now divide above by sine a. So if we divide this by sine a, it will be cos a minus sin a plus 1 upon sin a, and it will be cos a minus sin a minus 1 upon sin a. Okay. Now split sin a. It will be cos a by sin a minus it will be sin a by sin a, and plus it will be 1 by sin a whole upon. Now split this, will be cos a by sin a minus it will be sin a by sin a, and minus it will be 1 by sin a. Why I divide this by sin a? Because here we have we need to change it in the form of cosec and cot. Okay. Now here we have 1, and we know that 1 upon sin is cosec. Sin and sin will cancel out, and cos upon sin is cot. That's why I have divided this by sin a. Okay. Now here we have cot a minus 1 plus cosec upon again cot a minus 1 minus cosec. Here we have cot a 1 cosec a, cot a minus 1 minus cosec a. Now if you take cot a plus cosec a as it is, now this minus 1. So in place of 1 I can write cot square a minus cosec square. In place of 1 I can write cot square a minus cosec square a. No. It will be cosec square a minus cot square. Will be cosec square a minus cot square. Okay. And from here we have cot a minus cosec a minus 1. Here I didn't change because after solving this we will get this as a common part, and this part and that part will cancel out each other. Now here we can apply identity. It will be cot a plus cosec a, and here we have identity a minus a square minus b square. It will change into a plus b into a minus b whole upon cot a minus cosec a minus 1. So there are two terms, this and this whole term, and cot A plus cosec A, cot A plus cosec A. If we take cot A plus cosec A as a common, cot A plus cosec A common, so from here we are left with 1 and minus sign, and from here we are left with cosec A, then minus and minus will minus will turns to plus. 1 minus cosec A plus cot A, but here we have plus 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 1 plus 1 and plus. Okay, so now it will be cot A minus cosec A plus 1. Now we can see cot A, cosec minus cosec, 1, 1. These terms, both terms are same, so they will cancel out each other, and we are left with only cot A plus cosec A. So it is our right hand side. Okay, so we have solved uh, we have solved which part? Mm, fifth part of question number 4. Okay, now we will move forward because I am getting late. So now if you see the next question is very simple. In such type of questions, what you will do, now here we have 1 plus sign, 1 minus sign, and this is under root, square root. Okay, and we need to change it sec into sec A plus 10A. So first we need to solve this square root. So for that we need to rationalize it, and then we will see what would happen. So here we have left hand side square root 1 plus sin A upon 1 minus sin A, 1 minus sin A. So if we rationalize it, we will multiply it by 1 plus sin A, and we will multiply it by 1 plus sin A, because here we have minus, so we will multiply it by plus 1 minus sin A into 1 plus sin A. Okay, so now here it will be 1 plus sin A, 1 plus sin A, it will be 1 plus sin A whole square upon here a minus b, a plus b, it will be a square minus b square. Now as we know that this will be 1 plus sin A whole square, and it will be 1 minus sin square A. This is cos square. Okay, now here we take square as a common, so it will be 1 plus sin A by cos A whole square. This square will cancel this under root, so it will be 1 plus sin A upon cos A. Now split it, so 1 upon cos A plus sin A upon cos A, and 1 upon cos A is sec A plus 10. I think that is our right hand side. Okay, so we have solved the question, sixth part of question number 4. Similarly, we have this question. So what you will do here, from here you will take sin theta as common. So if you take sin theta as common, it will be sin theta, and if 1 minus 2 sin square theta, and if you take cos theta common, so it will be 2 cos square theta minus 1. Now that one will be sin square theta cos square theta, and and we will change this one as sin square theta plus cos square theta. See what happened. So here we will sin theta and sin theta will cancel out each other. So we will left with cos square theta minus sin square theta, and here it will be again cos square theta minus sin square theta will cancel out each other, and we will get tan theta. So this question is also very simple. Let me solve this. So question is, left hand side is sin theta minus 2 sin cube theta upon cos theta 2 cos cube theta minus cos theta. So from numerator we take sin theta is common, so it will be 1 minus 2 sin square theta. And from denominator we take cos theta is common, so it will be 2 cos square theta minus 1. Now it will be sin theta upon cos theta. Now here we have 1. In place of 1 I can write sin square theta plus cos square theta minus 2 sin square theta, and here we have 2 cos square theta minus. Now we will place sin square theta plus cos square theta in, okay, and now that minus, if we open the bracket, that minus will minus will change, and here we will both we will have negative sign. So now sin theta upon cos theta is tan theta, sin theta minus 2 sin square theta, so it will be cos square theta and minus sin square theta whole upon 2 cos square theta, it will be cos square theta minus sin square theta. They will cancel out each other, so we are left with only tan theta, and I think that is our right hand side. Okay, so now we have solved 7th question. If you see 8th question, so similarly it is very simple. I think you will apply identity, that is of a plus b whole square, a plus b whole square. Okay, let me solve this quickly. Now take left hand side, because I am getting late here. Sin a plus cosec a whole square plus cos a plus sec a, cos a plus sec a whole square. Okay, so if we apply identity, so it will be a square minus b square, so a square plus b square plus 2a into b. Similarly here we have again a square plus b square plus 2a into b. Now that sine and that cos will be 1. Sin square a cos square a is equals to 1 plus, from here we can change it into 1 upon sine, and sine and sine will cancel out each other, so it will be 2 sine a into 1 upon sine a, plus similarly here it will be 2 cos a into 1 upon cos a. Now we are left with cos square a sec square a. Cosec square a plus sec square a. Now this sign will cancel out, this cos will cancel out, so 1 plus 2 plus 2, that is 5, plus now sec square a plus cosec square a. What is the identity of sec cosec? Yes, Cos sec, we know that it is 1 plus cot square a, and sec we know that it is 1 plus tan square a. Now 115, that will be 7 plus tan square a plus cot square a. I think that is our right hand side. It is our right hand side. So we have done up to question number 8. There are 2-3 questions left in this exercise. We will try to solve it in the shorts. We will not shoot lecture for that those questions. Okay, so thank you so much and have a nice day.